Welcome back, Algebra 2. Here we go for section 4 today. We're talking about properties of logarithms. I'm going to tell you right now, don't slack. Don't slack on these notes, all right? I highlighted it, I wrote it, I'm taking the time to verbalize it. Don't slack on these notes. This one section right here, we are going to use basically throughout the rest of this chapter. Okay, maybe there's one section where we're not going to use this information to finish out the chapter, maybe just one other section, but you will be using this information pretty much for the rest of this chapter. Okay, so this is important. There's plenty of charts. There's 5. You need to copy them all down. Okay, these are charts that you're going to have to understand, have to know how to use. And this one section right here sets the foundation for that. Okay, don't slack. Here we go. All right. First 4 charts right here. You can see them. You're going to have to use them. Key pieces, product property. Notice we're using addition. Okay. Product property, notice we're using addition. That's something to notice. The quotient property, notice we're going to use subtraction. Okay, quotient using subtraction. Little connections, little cues so that you know what am I actually going to be doing here. Okay, next one, the power property. Notice right here that you're going to have something brought to a power. Power property, something brought to the power. Again, power property. Notice the 3. Where does it go? It gets moved in front. Okay. For the power property, notice the location. It gets moved in front. Okay. So you're going to see us use the power property when you're dealing with an exponent. And then you're going to move that exponent to the front. Notice that's where it is. Okay, inverse properties. This key piece right here, the base and that whole number have to be the same, or this coefficient and the base right there has to be the same. If it is, this will work. Here's your example. You got a log with a base 10. That whole number right there, 10, it will work. Or you got this coefficient 10 here, and then a base 10 here, that will work. Those just have to be the same. It's not like they have to be 10, but they have to be the same. And that's all about inverse property. Okay, last chart, changing the base. Okay, changing the base. And the key thing that I actually do for this, what we're going to call it, I know that we're not there yet in the example problems, but you're going to see right down here, we're going to use a change to a base 10 method. Okay, so this change to a base 10 method is what goes right here with the change the base formula. And I'm going to show you how to do it with the change to a base 10 and stick to that. Now the textbook shows you one other method. I don't prefer method 2. So if you look at the textbook, I'm focusing on method 1, which is change to a base 10. I believe it's more consistent. Yes, you do need to use the calculator for the change to a base 10 method, but we always have access to the scientific or graphing calculator. So that's why I think it's a little bit easier. It's a little more consistent. And yet you're always going to have the calculator with you. So it should work every time. Okay. Again, 5 charts. Copy them down. Take the time. Don't slack in this section. Here we go. Let's go through some example problems. All right. So first example problem here. Notice we are dealing with a plus sign. So we're using the product property because of that plus sign. All right. So we can rewrite this. Let's do that. So we have log with a base 1/3, and then this becomes 27 times 1/9, which basically when you work it out, it's 27 over 9, which becomes 3. So this is actually equal to log with a base 1/3. And this whole number right here is going to be 3. Okay. And this equals x. So now what you need to remember is in the previous sections, because all of this keeps working together, how do we rearrange this to go from a logarithmic function into an exponential function? Okay. And what we're going to be looking at here is really, let's see, a 1/3 to the power of x, which equals 3. So we're rewriting this, and then you have to solve for x, and your little q, if you will, should be the fact that you have a third and 3, and if you flip 1/3, it becomes 3, right? Well, you need to remember back to that last video that we did, where if you use a negative exponent, it flips a fraction. So that would mean that x has to equal -1. So in other words, if you take 1/3 and bring it to the -1 power, it will flip the 1/3, making it 3. So that right here is why flipping it, that's the key piece to knowing, oh, it's a negative exponent. I need to flip this number. Okay, let's take a look at number 2. All right, so the cue here is that it's subtraction, telling us we are using the quotient property. So very similar to the product property, except now we're using division. It's a quotient. All right, so we have a log with a base 7, and then we're looking at 49 over 7. So this is really log base 7, and then it's whole number 7. Well, in these situations, again, it goes back to what you learned in the last section. If your base number is the same as your whole number here, that tells you something. Again, your base number is the same as your whole number here. That tells you something. It's equal to 1. That's always the case. If your base number is equal to the whole number right there, it is equal to 1. So a log base 7 with 7 is equal to 1 because they're the same number. All right, again, that's something we learned in the last section. Okay, let's move into number 3. The clue here is this is a power property. So we're using the power property chart. And there is a nice, helpful thing is when you have any problem that doesn't put a number right here, that means there's actually a base 10. They never write it. Okay, this is like saying x, but really you know that it's 1x. They're never going to write that 1. So if they leave this blank, that's because really there's a 10 right there. This is why this is so nice, is because your calculator already works with log base 10. So you could literally plug this into your calculator. Now, look in the first column, and you're going to see log right there, push log. It's already in a base 10. So then go ahead and put 10, and then that little upwards arrow in the column to the far right. Then put a 4, close parenthesis, hit enter, and you will get 4. All right, so anything with a base 10, use the calculator. Plug it in, and you get 4. Those are straightforward. Don't even need to worry about it. Don't even really need to know the properties because base 10s will work out perfectly. But let's take a look at number 4. What if it doesn't have a base 10? So now we have to understand the property behind this. Okay, so if we are looking at the power property, this guy right here is going to get moved. Okay, so this 5 right here is actually going to get moved in front. So we're going to rewrite this to have a 5 log base 2, then 1/2, and then we're going to say equals x. Now, for the time being, I don't want this 5 right here to be used yet. Okay, so imagine that this 5 isn't here, and I want you just to solve this part right here, which we know how to do because we did it in the last section. So let's do that. You would rewrite this, and it would be 2 to the x power equals 1/2. By now, you should start getting used to this. You see you have a 2, and you see that you have basically a flipped 2, 1/2. That means the exponent must be a -1. All right, so we got to start getting used to this. X equals a -1. But we're not done yet, because now we need to incorporate the 5. So what we just figured out is that this right here equals -1. So now you need to take -1 and multiply it by 5, giving you a final answer of -5. Okay, so this is all about the power property, because this right here is our power brought into the front. Solve this part first, then multiply it by that number that you brought out to the front as your final step. Okay, all right, let's move it down. Now we're going to be using the inverse property, but what do you notice? You should see something. We are lacking a base, which means we are actually looking at another base 10. So how do we do this? How do we plug this into the calculator so that it works out perfectly? Again, push log. We already know the calculator is programmed to have base 10. So then you're going to push 10, and then that upward arrow, 0.9, close it, and then hit enter. Now let's see, we should be looking at simply a 0.9, which is perfect. So that would mean we have just 0.9. Okay, now again, that's how you do it with the calculator. But now let's use the actual inverse property and do one that we can't use the calculator on. This is just using the property, using the chart. Okay, here's the key piece you need to see. Your coefficient here, your base number here have to be the same, and they are the same. So now go back and look at that chart. If those two values are the same, and remember, we're using the inverse property chart, then you are simply looking at this as your answer. You're simplifying an inverse. These numbers right here have to be the same. If they are, then your answer is just 8x. So they're both 2, so we can use the inverse property chart. Okay, now we got one more problem to do. Okay, so here comes the change to base 10 method. All right, now if you look in the textbook, this is usually going to be their first method, their method 1. Okay, I don't recommend using the method 2. Method 1 stays very consistent. You'll always have access to that calculator. So let's go ahead and use method 1, change to a base 10. All right, so if we change to a base 10, what we're going to do, let's rewrite this so that we will no longer have this base 9. All right, that's not going to be the case. We're going to change it to a base 10, but we got to rewrite the whole thing to do that. So here's what we're looking at. A log with a base 10, and then the 27 divided by log with a base 10, and now that whole number is 9. Now remember, the calculator, being our friend here, is already programmed to have that base 10. So really, you plug it in, and let's go ahead and do that. If we plug in log 27 you get a fairly long decimal answer here. 1.4313. And it does keep going. So we can have what, 6.3? Yeah, it keeps going. Okay. Divided. Now here's a little trick with the calculator. Okay. So we're just now going to hit the division sign, and it's going to take that answer that you just got. So you should see ANS and then slash, meaning answer divided by, and then go ahead and hit log 9 and close the parenthesis, hit enter, and you should get exactly 1.5. So I'll rewrite this here. We did log base 10 9 equals 1.5. All right, that's exactly how to do it. That covers all examples for section 4, an important section with all those properties. All right, ask questions if you got them. Keep working hard. All right, you guys can do this. I'll see you in the next one.